Hello, hi everyone. Very good evening to all. Um, I hope I am live now. So let me just first of all uh, get a quick confirmation on the same, and after that we will start our discussion very soon. Um, YouTube also started giving the notification a few minutes back, so I'm assuming that many people will join. So let me check in the meantime whether I am perfectly audible or not. By the way, I hope that you guys have seen from the banner itself what's the topic for today's discussion. Let me just send the reminder to my WhatsApp community as well, and we'll start our discussion within next few minutes. Uh, Today I'm live again. Yesterday also we were live. It's just that today I was not having any meeting at night, so I thought that let's use this time to have a dedicated session, right? So that's the reason I'm live again. I hope I'm perfectly audible, clearly visible to everyone. So, in the meantime, the people who have joined us, can you guys give me a quick confirmation? Am I clearly audible to everyone? Is my voice as clear? We will start our discussion very soon. I am pretty sure many people will join. So let's wait for a few minutes so that everybody will join our discussion, and then we will start our discussion. In the meantime, let me share my screen as well, and let's see whether my screen is also properly visible to everyone or not. Okay, so uh, hi everyone, those who have just now joined us. Today we will be talking about a very interesting topic, where we will discuss about how actually any e-commerce specific platform um, tries to do a recommendation part. For example, if let's say today I want to purchase a camera, I went to Amazon and I added the camera, whatever be the camera I want to book. So automatically, at the very end, it starts giving me a recommendation that ideally you should also make a purchase of a tripod. And genuinely, when I see the recommendations, I observe that this is something which I also required. So I usually take all of the products which are suggested by the Amazon, and that's how the things work ideally, right? So I hope the same feature, the same sort of things you also have observed at your end. uh, can you guys give me a confirmation in the chat window? देखा है आप लोगों ने? Amazon is one of the example, but ऐसे बहुत सारे examples आप लोगों को मिल जाएंगे. Netflix, अगर आप एक मूवी देखते हो तो ऑटोमेटिकली आपको वो सजेस्ट करता है कि ये स्पेसिफिक मूवी भी आपके लिए रिकमेंडेड है. ऐसे ही प्राइम, आई मीन all the platforms which we are using right now, they have a recommendation system, and based on our history, based on our products which we are purchasing, it is giving us the recommendation and uh, kind of a notification that people prefer to buy these things together in pair. I hope everybody have seen that. Yes, everyone. Can I get a quick confirmation? Now I think many people have joined. So can I get a quick confirmation? Am I clearly audible, perfectly visible, as well as can you just see my screen as well? Quickly, if you can just give me a confirmation, we can start our further discussion. So ideally, we will start with the core pipeline of how the ML project looks like. Then we will talk about that this specific topic comes under which specific portion. And by the way, I have never discussed this specific topic in my past, in my YouTube videos. So this is ideally a very first discussion which I am having on my channel. So definitely you will learn a lot. So please utilize this time and take it as an opportunity to learn from the specific discussion. In between, if you face any specific doubt, कुछ भी प्रॉब्लम है, कुछ भी अगर क्वेश्चन आ रहा है दिमाग में, सो प्लीज बी अटेंटिव एंड आस्क इन द चैट विंडो. दैट्स द बेनिफिट ऑफ अ लाइव डिस्कशन, राइट? Otherwise, I can also record a video and share with you all. But the main benefit is I can interact with you all, and that's the reason I personally prefer to come on live again and again, right? So when we talk about any machine learning project, first of all, I hope everybody in this specific uh, live knows what exactly is machine learning. So we know that over here in this specific portion in data science, we actually try to train our model based on the past historical data, and our main focus is to work on a numerical data. So over here, we usually work on a numerical data, right, everyone? And the main focus is to train the model based on a historical data so that the models start taking the decisions without having any human intervention. So that's the end goal, right? I hope everybody knows that. Right? Is my screen is perfectly visible to everyone? Let me just add the size so that it will be perfectly visible. Now I think it should, right? Okay, so that is the end goal. Everybody knows that. That's the end goal of a ML model. That's the end goal of a machine learning model. Now, when we talk about machine learning pipeline, when you work in any specific firm, yesterday also we had a live discussion where we have seen how the process started from understanding the business problem and how it went till data deployment part or model deployment part. Now, over here, we usually try to see that first of all, whether the data is labeled or not. So based on that, we have two types of ML models. We have two types of, I would say, separate classes of machine learning problems. One is what we call as supervised machine learning. Another one is what we call as unsupervised machine learning, right? Now it depends that whether the data which is given to you is labeled or not, right? So over here, depending upon this condition, that whether you have a labeled data, what is the meaning of labeled data? It simply means that whether you will be having a, I would say, target class available or not. For example, let's say you are trying to diagnose any specific disease, for example, diabetes. So over there, if you have a target column which is specifying that this specific patient has a diabetes and this specific patient does not have a diabetes, this is where you will say that, okay, we have a labeled data available. So either you have a labeled data available or you don't have. Now, depending upon that, we have two types of categories, which I am assuming everybody knows. So if we have a labeled data as a yes, so we classify that specific problem as a supervised ML. If we don't have a labeled data, we know that it will be classified as a unsupervised machine learning model. ठीक है जी. So we know about machine learning. We know that based on a labeled data, we have two categories of ML specific problems, supervised and unsupervised. Acha, after that, I hope this also everybody knows that depending upon if we have a labeled data, what is the type of that specific label data? Is that label data is having a continuous values, or a label data is having a categorical values, right? If let's say your target column contains continuous values, for example, in my YouTube channel itself, you will find one video on house price prediction. हाउस प्राइस प्रेडिक्शन देखा है आप लोगों ने वो वीडियो? काफी अच्छा वीडियो है वो, जिसमें मैंने एंड टू एंड आप लोगों को शोकेस करके दिखा रखा है कि कैसे एक आइडियल तरीके से एमएल के अंदर हम वर्क करते हैं. दैट्स अ वेरी गुड एग्जांपल, हाउस प्राइस और फ्लैट प्राइस प्रेडिक्शन. सो दैट इज वेयर यू विल ऑब्जर्व कि जो हमारा टारगेट कॉलम है, दैट इज द प्राइस ऑफ दैट फ्लैट और द हाउस. So that is something which we can say is a category of what I would say is the regression specific problems. तो एमएल के अंदर हमारे पास रिग्रेशन मॉडल्स होते हैं स्पेसिफिकली जो कि हैंडल करते हैं दैट स्पेसिफिक काइंड ऑफ अ डेटा where target is a continuous value. I have already shared with you one example. और इनफैक्ट आपको इसका वीडियो भी मिल जाएगा एंड टू एंड इफ यू हैव एनी इशू. फिर एक और कैटेगरी होती है, ये भी आपको मिल जाएगी एक वीडियो, मशीन लर्निंग प्लेलिस्ट के अंदर ही सब मिल जाएगा आपको. दैट इज कॉल्ड एज कैटेगरिकल टाइप ऑफ मॉडल्स. कैटेगरिकल आई वुड से टाइप ऑफ कॉलम्स जहां पे हमारे पास कैटेगरीज होती हैं. एज एन आउटपुट हमारे पास क्या होता है, कैटेगरीज होती हैं. जैसे कि you have the binary classification task 0 या 1 where your main goal is to detect whether the patient is diabetic or not. तो अगर patient diabetic होगा तो the class is 1 और अगर नहीं होगा तो class will be 0. So over here we'll have, let's suppose, two classes that whether the patient will be diabetic or the patient will be non-diabetic. So over here you will observe कि there is one more category based on this type of target value which we called as classification based models, है ना. इसके basis पे we will be having two separate categories. So the next one is classification model where we have a target which is nothing but a categorical entity measured as 0 or 1. ठीक है जी, this is also done. Now today I have already, in my ML playlist have talked a lot about this regression based problems and its models and this classification models. For example, logistic regression, decision tree, random forest, XGBoost. There are so many models which I already have covered up as a part of a classification model. Today's session is something interesting which I have not covered up at any point of time in my discussions. That is about unsupervised ML. अब आप बोलोगे अनसुपरवाइज में क्लस्टरिंग डिस्कस हुआ. सी व्हेन यू हैव unsupervised means you don't have a label data, you don't have a target column which is available. So in that scenario you again have two options. Do you want to do a grouping? So if you want to do a grouping of the items, that is where in unsupervised model we have the clustering algorithms, and you might find the video for this as well, where we want to create a clusters, we want to create a group of similar patterns, similar items. The second part of unsupervised ML is what we called as association, जिसके बारे में आज हम बात करने वाले हैं. This is the main focus for today's session. Association based algorithms, you can say, or based rules. This is kind of a rule based algorithm. This is a kind of a rule based algorithms. So over here, when I will just try to when I just try to implement this is what we will be able to get, right? So that is the complete flow chart. So now we have to understand association means how the two products are connected, how the two features are connected, whatever you want to purchase. So if let's say anyone is going to purchase bread, so what is the probability that person will also purchase butter? If anyone is going to purchase milk, what is the probability that he or she will also purchase a bread? So that is where the association or a rule based algorithm will come into picture. So now this is what we have to cover up today, right? I hope the objective is clear to everyone. Is the objective is clear? Can we get a quick confirmation from everyone over here? Now over here you will observe that when we talk about association based rules, we have few keywords which we have to understand. So whenever we talk about association specific rules, the very first key term that we have is what we call as anchor. Now what is the meaning of anchor? Anchor means the primary item which the customer is interested to purchase. This is kind of a primary item, you will say, that the customer actually came to buy. For example, it could be a bread. right? Because that is a purchase which happens almost on a daily basis, right? So we can say that maybe a person actually came to purchase a bread, and that is the anchor item that we will be having. Now, after this, we have a second interesting keyword which we call as attachment. After an anchor item, we have something called as attachment. What is the exact meaning of attachment? Attachment means that, what is the best friend item for that anchor product. So attachment means what is the sort of a, you can say, best friend item that we can say usually follows the anchor, that usually follows the anchor product. फॉर एग्जाम्पल अगर कोई आता है और ब्रेड खरीदता है तो देयर कुड बी हाई चांस कि वो बटर खरीद रहा है. सो वी कैन से दैट बटर इज द अटैचमेंट एंड ब्रेड इज द एंकर प्रोडक्ट इन अवर case, in our superstore market, right? Now, in order to understand this association rule, we need to understand the three key terms over here. The first key term is what we call as support. What do we understand by support? What do we understand by support? Any guesses, anyone? Do you guys have heard this term, support? Support means how frequently an item appear in your data set. What is the meaning of support? It means that how frequently the item appears in the data set. Item set appears in the data. In terms of the probability world, we call the support of product A given product B is nothing but the probability of A intersection B. This is the inference in terms of probability. So if let's suppose I'm sharing with you that the probability of item A is, let's suppose, 60%, and the probability of item B given that a person has already purchased item A is, let's say, 0.35. So what is the probability of A intersection B? What is the probability that the customer will purchase both of them? That is what we call as support. Now, do you know how will we evaluate the probability of A intersection B? Do you know how will we evaluate the probability of A intersection B? At any point of time, have you learned about the concept of conditional probability? So if you know, in conditional probability, we say that the probability of B given A is nothing but the probability of A intersection B divided by the probability of A. If you don't know, just today only check about this concept. This is a very important concept in the probability part. This concept is called as conditional probability. This concept is what we call as conditional probability. So over here, based on this specific concept, if I want to evaluate what is the probability of A intersection B, I just have to multiply these two keywords. So it's nothing but probability of B given A into probability of A. So it will be 0.35 into 0.60. And when we evaluate this, whatever be the answer we are getting, it is approximately 0.21. This you can call it as a support. I hope the meaning of this support specific term is clear to everyone, right? So it means simply कि आपके पूरे डेटा में जो sort of pairing है जो आप कर रहे हो कि ब्रेड के साथ बटर आएगा वो कितनी बार आ रहा है, अगर इन जनरल अगर मैं आपको ये समझाऊं तो, right? Just to give you one small example, let's say in the whole day, let's say I'm the owner of a grocery store, and let's suppose कि in total I am saying that in my shop today 1000 total transactions happen. ठीक है, मतलब कि 1000 total customers मेरे shop पे आए. ठीक है, now out of 1000 total transactions, 100 contains both bread and butter. 100 contains both bread and butter. So now if I'm asking you a question that can you just let me know what is the support value over here? Can you just let me know what is the support value over here? So can you evaluate it and let me know? Can you just evaluate it and let me know? What do you think will be the support value over here? So we have in total 1,000 transactions. Out of them, let's say in today's day, 100 people came to buy both bread and butter. So what I'm saying is, what is the value of the support? So it is nothing but how many transactions happened where we will be having the customers buying both of them divided by total number of transactions, which is 1,000. So it is nothing but 0.1. So this is something which we call it as a support value. Now, the key insight will be that if at any point of time in your work, you are getting a high support, it specifically indicates that the rule which you are applying is mathematically, statistically significant. Right? That's the meaning of, you can say, having a high support value. हाई सपोर्ट का मतलब क्या है कि बहुत ज्यादा फ्रीक्वेंटली दोनों प्रोडक्ट्स ए और बी साथ साथ आते हैं. इसका मतलब रूल आपका कहीं ना कहीं वैलिड है, वैल्यूएबल है आपके डेटा के अंदर. लेकिन अगर आपका सपोर्ट वैल्यू लो है, इफ यू हैव अ लो सपोर्ट वैल्यू in that specific use case, what will happen? It simply indicates ki just ignore this because that combination is too rare. And that's the reason that combination is not useful. I hope this conversation is clear to everyone. So what we have understood till so far, that in machine learning umbrella, where exactly this association rules will lie, and in that, what is the exact meaning of association rules? What do we mean by anchor and attachment as a key term? Main hero and the attachment is the best friend of that hero. And then the first key term, the first parameter, the first measure in association rule is what we call as support, which indicates that how frequently an item appear in a given data. Clear, everyone? Now let's talk about the second specific indicator, which is again a very interesting measure that we have. You will heard about this, which we call as confidence. अब ये कॉन्फिडेंस वो वाला कॉन्फिडेंस तो नहीं है जो हम नॉर्मल इंग्लिश में यूज करते हैं, बट इसका इंटरप्रिटेशन सिमिलर सा ही है. सो वी हैव समथिंग कॉल्ड एज कॉन्फिडेंस. जस्ट गिव मी अ सेकेंड. So what do we mean by confidence? It means that how often, kitni baar, you can say B appears, how often B appears when A is already present. When A is already present. So it simply indicates ki how often the item B appears when A is already there. So basically you want to determine over here confidence of A given B is probability of B given A. This is nothing but you are trying to evaluate what is the probability of B when A is already present, right? That's how the definition looks like as well. And we already know, just few minutes back I talked about the conditional probability formula. It is nothing but what is the intersection value of A and B divided by the probability of A. So it means that if I will share with you the number of this support or indirectly how often the two items appear together and the probability of A, that how many times the people are purchasing alone this A item, I think you will be able to evaluate the confidence value. Just give me a quick confirmation on it. Yes or no? Is this clear to everyone? All good? So basically, if let's say I will say over here that let's suppose almost 200 people are there who have bought the bread. ठीक है, मैं ये बोल रही हूं कि 200 लोग हैं जिन्होंने ब्रेड खरीदा, एंड देन देर आर 100 पीपल who have bought both of them, bread and butter, who have bought bread as well as butter. So in that case, if I will try to evaluate what is the confidence value, so it is nothing but what is the intersection value? It is 100 divided by what is the probability of getting alone an item A, which is 200. So when we evaluate it, it will be 50% or 0.5. And this is something which we call as confidence. If we have a high confidence on any given item, obviously we will say that, the rule is quite high, the rule is quite good, we are doing a very good pairing. But this can be misleading as well. And it could be the case that, the number which is coming over here might be a coincidence. It might be the case that people are not genuinely want to purchase these products in a pair. For example, today in the morning itself, I was purchasing something on Amazon, and it was just showcasing me very weird product with the pairing of that. So it could be the confidence value, which might be very high. But if we look on to the second parameter, which I'll talk about over here, the lift, it could be low. So before we will jump towards the next important measure, which we call as lift, is this clear? Confidence meaning is clear? So I hope till so far we have understood what exactly do we mean by support and how can we evaluate it? What exactly do we mean by confidence and how can we evaluate it? All good, everyone? थोड़ा आगे बढ़े? All good? Shall we move ahead? Now in the next part, we will talk about something called as lift. What do we mean by lift? Lift means how much better your rule is compared to a random choice. So you're somehow over here comparing ki whatever rule you have designed, how much better that specific rule is. How much better your rule is comparable to any random choice. Any random choice. So basically over here, when we try to evaluate the lift of A given B, it is nothing but is equals to what is the probability of A intersection B divided by the probability of A into probability of B. So basically over here, the question is ki when we have two products, does A actually influence B? Does A actually influence B? Or is it just a coincidence? Or is it just a coincidence? And that's what we are trying to evaluate over here using a lift value. So this is the formula to evaluate it. Now, if the value of lift is equal to 1, let's say you evaluated the lift value and you are saying that this value is approximately equal to 1. It means that there is no sort of relationship between the two items. If let's say you're getting the value more than 1, it means that there is a positive association between the products. And if it is let's say less than 1, it indicates that there is somehow the negative association between the products. So usually we try to evaluate this lift value and we see that where the positive association is there. And this is indicating a useful rule. So in the designing part, when we recommend the items to the users, we always look for this lift specific parameter and we check that wherever there is a positive association, it means that there are high chances that customer will prefer to buy the products together, right? Is it really works in the real world? Definitely yes. Just now I will, in this session, we'll talk about one very interesting algorithm. We'll see the perfect implementation of it and you'll get to know how it actually works. To understand that algorithm, this is the major prerequisite. You should know about what exactly do we mean by support, confidence, and lift. I hope it is perfectly clear to everyone. Shall we move further? So basically, if you will be able to evaluate, um, in other words, the value of confidence, and if let's say I will give you, so somehow this is nothing but is the confidence value. Few minutes back we have done the evaluation of it. And then if you will just divide it with the probability of B. This is confidence value. And then you just have to divide with the probability of B. So the another formula which we got over here is confidence divided by the probability of B. Right? So if let's say I will give you a question that, butter is something which is already bought by 80% of people. Butter is something which is already bought by 80% of people. Okay? So basically, I'm giving you the somehow probability of B, which is nothing but is equals to 0.8. And the confidence value uh, is also, let's suppose, 0.8. Confidence value which you're getting is also 0.8. Confidence of having the bread and butter purchase. Of having the bread and butter purchase. I'm giving you one scenario. So you will evaluate the lift value by just dividing the confidence value with the probability of B. And you got it as 1. So it indicates, the meaning of this value is, it indicates that buying bread does not increase the sales of butter, does not increase the butter purchase, right? There is no as such a strong association between these two. Butter itself is already popular and that's why people are purchasing it. See, there is, as we have discussed, one hero product. Now it could be the case that whatever be the influence product which you're talking about, it could be the case that it's already popular. So it's not something which is influenced by item A. People are purchasing it alone as well, right? And that's the true indication which is given by the lift specific parameter over here. Okay, I hope till so far everything is clear. Now, actually, when we talk about real world scenarios in the entire picture, there is one algorithm which works literally inside this. And that is where we will have to talk about something called as FP algorithm. So it uses FP specific algorithm, FP growth, which helps us to group the items together. So now we have to understand that how this grouping will happen. And that is what we have to understand over here. So let's start our discussion on that. And for that, I will take a very simple example. So let me try to, first of all, copy one example, and then we can discuss how this FP algorithm will work. FP means frequency and the priority based algorithm. And by the name itself, you will be able to understand it, how it works effectively. Now, I have talked about today bread, butter, those examples. But in this algorithm, I will take some random alphabets. You can understand that these alphabets are not any weird numbers. They are just like a product only, right? So let's say I have the IDs over here. And I have its corresponding items. I have its corresponding items. Now let's suppose I have the ID available from 1 to 9, 6, 7, 8 and 9. And corresponding to it, I have an item list, which is like S, Q, R, Q comma T comma P comma S. These are the items which the person has purchased. Now it could be bread and butter, bread, butter, milk, and some other two products like that you are considering. You have to consider. Then S, then PST, then R, P, Q, and T, then T, P, S, and Q, then Q, P, and S, then we have Q, R, and U, and finally we have U. Now, based on these items, what we have to do first? We need to create something called as FP chart. So basically, we need to segregate the unique products that we will be having. So over here, we will be having a product specific list. So it is nothing but P, then Q, then R, then S, then T. After this, based on that, what I will do is I will just count the frequency, and based on the frequency, I will provide the priority of the item. So obviously, any product which is having a high frequency, I will assign the high priority to that specific product. So I have already counted it down before this session. The frequency looks like 5, 6, 3, 6, and 4. So this is the frequency of individual products that we will be having starting from P to T. Now, based on that, we have a priority of a product. So over here, you can see these two are having a high frequency. So whichever product comes first will be assigned a first priority. So this will be having a high priority. Then second one is this. Third one is this. Fourth one is this. And fifth one is this. So in this way, we will be having a priority from 1 to 5 of all the items that we will be having. Now what we have to do? We have to structure our products in an ordered item way, in an ordered pattern way. So what will happen? With respect to S and Q, Q is having a high priority followed by S. So I will write it down, Q comma S. Then with respect to R, Q, T, P, S, I will write, first of all, Q will come, then S will come, then next priority will go to P, then T, and then R. Just let me know wherever if you feel something is going wrong. Then we just have a single product, so S will be the one. Out of PST, if I have to again reorder them based on a priority order, so PST, S will, S will come first, then P, and then T, right? So S will come first, then P, and then T. Similarly, for this, Q will come first, then P, then T, and then R. Q, S, P, and T. Q, S, and P. And after that, at the very end, we have something called as Q, R, U, and U. Now over here, what I have done is I have just prioritized my entire items in the base of priority order, right? I have prioritized them based on the priority order. Okay. Now over here, what we will do? In FP algorithm, we try to decide, let's say, a support value. And we are seeing that if any item is having a support less than 3, maybe disapprove that item because that item is appearing very rarely. Okay? So if you will count this entire set of items, there is only one item, which is U, which is appearing very rare, having a support as 2 items are there. And apart from that, remaining items are appearing at least more than 2 times, right? Okay. So I have just disapproved that rarest item, which is U over here. Now what I will do? I will design a tree over here. Now I hope everybody knows that when we talk about tree specific data structure, tree is a non-linear data structure. Tree is a non-linear data structure. So over here, basically what we will do, we will try to start with a null value. And after that, we will try to keep on adding the nodes. So we will start with Q. And after that, the next node that we have is S. So after Q, we have something called as S. So that's how the pairing will be done. It means that this is one of the path where Q is there. So S can be also another possibility which a user can add or a Amazon can add as a product. Then we have QS. Do we have already available path for the next cycle where we can add further items? Yes, we have. So what we will do, we will just add the other items P, T, and R. So basically, we started with a Q and S. So we keep on tracking these numbers as well. So the frequency of Q and S in the initial part was 1 and 1. After that, what happens is, we went further. We have a second ordered item as QSPTR. So we already have a path. So we have just incremented the pointer over here. But P, T, R are the new items. So the frequency of them will be 1. It means that we have a path over here. For Q and S, it repeated 2 times. And for other items, it is just single time. Then we move ahead. Next is S. Acha, do we have any path where from the direct starting we are approaching towards S item? No, we don't have. So what we will do, we will create a path corresponding to it. And we will say we have S, again the value will be equal to 1, which indicates that this is the starting point. We moved further, then we have SPT. So what will happen? We again have a new path. Acha, starting from S, we have already a path. So what we can do? We can just use that specific path and recreate it further. So when we say SPT, S is the previous one, second time repetition. P and T are the new branches from there. So 1, 1. After this, further we will explore Q, P, T, R. So from null to Q, we already have a path. But after that, we have to recreate a new path for P, T, and R. Are you guys getting a point of it? How the items are paired up? So we have a Q, 3. But after this, we have recreated the path for P, T, and R as 1, 1, and 1. Is it fine? Is it fine to everyone? Then we further move ahead. We have QSPT. Do we have a path for it for this? Yes, we do have. So there is no need to recreate it. Just increment the pointer. For Q, for S, for P, and for T. Perfect. I think I have missed one pointer over here. So we have QS. So it will be 1 and 1. Then the next pointer we will be having QSPT. So it will be 2, 2. It is fine. Then we have SSPT, QPTR. I think it's fine. Now we again further move ahead. We have QSP. Okay, we already have a path for it as well. QSP. So Q is 5, S is 4, P is 3. Already we have a path. Amazing. We'll move ahead. We have Q, R. Do we have a path? We don't have. We have Q, but we don't have something called as R. So we will recreate a R over here. So Q will be 6 at the very end and R value will be equals to 1. So now you can see any product or any path which is appearing again and again, obviously there will be high probability of them to pair up, right? There will be high probability of them to pair up. So basically, can I say that this QSP item or this QSPT item is having a very high probability to pair up as comparable to other items? So that is where it actually created a tree based data structure, and based on that, it tries to decide the association corresponding to it. And that's how ideally it works internally. I hope it is pretty much clear to everyone. And that's the major thing which I really want to discuss over here. This is also, I would say, comes under a market basket analysis, which is the key term which you might have, you know, seen or have came across at your work as well, where we actually try to understand the invisible threads, which specific products will come in one specific basket or frequently bought together products. And that's why this is the common term which we use under here, called as market basket analysis. सुना है आप लोगों ने इस टर्म को? बहुत बार हम यूज करते हैं अपने एसोसिएशन वर्क के अंदर. So that is the overall idea about the specific part of discussion. Now what I will do is I will just try to go through with a simple implementation of it, whatever we have discussed just right now, and then maybe we will wrap up the discussion. So for now, I have already just picked up a random data pointers available with me. So you can see that we have a mini mart data set where we just have 15 transactions. Now over here, if I will just say there are 15 transactions we have, one indicates that a customer have purchased a product, 0 indicates customer have not purchased a product. So we have milk, bread, butter, beer, diapers, eggs, and coffee. So if I execute this, this is the kind of a mini mart which looks like this. Now if I'll ask you, hey, can you just let me know what is the support value for a milk? Can you just let me know? If I'll ask you, what is the support value for a milk? Can you just let me know? Or maybe how will you evaluate it? Can you just let me know? Based on whatever discussion we have done. Can you just let me know what is the final support value for a milk specific product? Look on to this and let me know. So you will observe over here that how many items are ones out of total items that we will be having. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 ones in the milk divided by, in total we have 15 products. So it will be nothing but 10 divided by 50. In this way, you can evaluate the support value for all the items that we will be having, which is milk, bread, butter, beer, diaper, egg, and coffee. And then you can just try to evaluate maybe the support value for milk and bread, the support value for milk and butter. You can also evaluate the confidence value. So higher the support value, it means that there will be high chances that that specific product will come together. For example, if I'll check for milk and bread, so I will check that, how often they both come together. So both of them will be having a value as 1 and 1. So this is 1, 2, 3, 4, 5, 6, 7. So in total, 7 times they appear together, divided by 50. So that's the support of milk followed by bread, right? So that's how we usually evaluate the specific parameters. Now, just now we have talked about FP algorithm, right? Which actually helps me to understand the market basket analysis part, or which specific items will come together. Now see this part of a code. So we have FP growth and association rules based function, which we have to import from this frequent patterns module. We have again taken these data entries. We have converted our data to a data frame. We named it as master data frame. What we have done is we have just converted our data to a Boolean, and after that, we applied this FP growth algorithm. Now, we have to always apply a minimum support value. In my explanation, I have given it as 3 items or 0.3. Over here, we are giving 0.2. It means that if there is any item which appears less than 2 times, just remove that item. That's a rarest item, so it's of no use. And we are saying that use the column names as it is, whatever we have: milk, bread, butter, and so on. Now, finally, we are applying an association rules based function, which will take the frequent patterns, which will take the metric as left, and minimum threshold we are defining as 1.2. So we are saying over here that if when you are trying to combine the two products together, or if you're giving me the answer of the association products, if there is a left value less than 1.2, remove the item. Or maybe don't give me that specific association part, because I am just looking for only those specific products which are having a higher left value. Okay? So that's why it's important to provide a threshold over here. So higher the threshold means I'm saying that, if the left value is beyond that, then only give me the results. Now, finally, I'm just trying to see all these measures over here. So if I'll just run the specific part, you can see now what are the different products which are paired up, what is their support value, confidence value, and the lift value. One thing you will observe over here, that all the items which I am getting over here, which are associated with each other, they have a lift value which is more than this threshold value, which is 1.2. And that's the overall thing that we have to understand over here. I hope that now it's clear to everyone how whatever pointers we have covered up over here actually makes sense. So we started our discussion by understanding the complete ML flow and where exactly this association rules will lie. Followed by, we have understood over here the important key terms like anchor, attachment, and the important measures. So these are the measures in association rule which we have to understand. So we have talked about 3 measures: support, confidence, and the lift. We have understood that why lift is a very important measure. And at the very end, we have talked about FP algorithm, which works internally to pair up the products. And finally, we have tried to implement them step by step. I hope it was clear to everyone. Do you have any questions? That's the overall idea which I want to give in today's discussion. If everything is clear, we can wrap up. Otherwise, you can ask me a question if you already have. Also, similar to these kind of discussions, these kind of topics, I have discussed in my specific machine learning guide course. So if there is anyone, many people are not aware about this. So if there is anyone who is actually looking to master ML specific stuff, right? So they can just directly see this specific course. It's a self-paced course only, but all the concepts with respect to machine learning I have covered up in a detailed way. You will find the recordings also of the past live discussions, plus the recordings of my proper shoot, right? So everything you will find in the specific course if you're interested in machine learning specific part. My recent course was this build 5 industry level data projects. You can also explore this. Over here, I have talked about the end-to-end projects with respect to the domain of data specific world, whether it's about data analyst or data science. So you can just go and explore these courses. I mean, many people are still not aware about these stuffs. That's why I'm talking about again and again. And then they usually mail me, ki, how can we, get the expertise on these specific topics. Similarly, this mathematics for data professionals. This one is also latest one where only the mathematical part have been covered up, because lot many people in the starting were asking to me that, when we talk about maths, we're very confused. What specific mathematics we have to learn? We are not really good with maths. So can you just let us know exact mathematical part? So over here, you will find at least the curriculum. You can see if you want to do it by your own, that's your choice. Or you want to do it from this course itself. Again, that's your choice. But You can definitely go through with the course curriculum and you have to check what are the important topics that we have to know when we want to deep dive into the world of machine learning or data science, right? So you can just go and explore everything. This is available on my website. And with that, let's end this today's discussion. I really hope that you find the session insightful. If you have any quick questions, you can ask. Otherwise, we can wrap up for today. Any questions anyone is having? Okay, there will be many people who might listen this session after this live discussion will be over. So if you have any questions after you check this entire recording, you can let me know in the comment section also. I usually read all the comments and will respond to you whenever I get a time. Uh, Also, please stay tuned. Join my WhatsApp channel group as well, where I usually announce the things on a daily basis, right? Whatever be the new course launches going on, or which specific project I'm currently working in, what are the next plans, right? So you can join that. Uh, and stay tuned on my YouTube channel as well. A lot of interesting things I'm planning in the coming months as well. So, yep, let's see. Seems like no questions. So, let's end today's discussion. I will see you all in the upcoming live discussion. I hope you enjoyed it. Bye bye, everyone. See ya. Good night.